Alright, this video is the concluding part of our chapter 12 on working with data, and we're going to look at two concepts today, the range and outliers in a set of data, and then we'll also kind of assess and give some hints on when to use certain measures of central tendency, when it's more beneficial than others. Okay, so first we're going to look at a little bit of data, and being in Canada, we're going to look at some hockey statistics from the 2005-2006 leaderboard. Okay, so some of these players are still playing. Actually, all of them are still playing. But this was the leaderboard about 9 seasons ago. Okay? 8 or 9 seasons ago. So the top scorer was Joe Thornton. Okay, and Joe Thornton scored 125 points. So that's goals plus assists. And then Jaromir Jagr scored 123 points. So pretty close at the top. And there's a bit of a drop, and this is Alexander Ovechkin, and it was actually his rookie season, I think. And as a rookie, he scored 106 points. Okay, and then Danny Heatley scored 103 points. I think he was still with Ottawa then. And his teammate in Ottawa, Daniel Alfredson, also scored 103 points. Okay, so here's a set of data. We are asked to find the range of this data. Now, the range of data is actually pretty simple to find. All you have to do is determine the greatest number and the smallest number, and we are looking at the difference between them. So a little formula to remember that. Range is equal to highest value minus lowest value. Okay, so what is the highest value? Well, I already ranked it for you. Joe Thornton scored 125 points. That would be the highest value. And the lowest value here, well, both Danny Heatley and Daniel Alfredson had 103. So we'll subtract 103. Okay, what's 125 minus 123? We're looking at 22 points as the range of this data. Okay, so range gives us a little bit of an indication on how close the data is together. Right? If we have a significant range, then there's a lot of discrepancy between the data. If the range is very small, that means all the data was pretty close together. Okay, so there'd be certain uses for this data. For example, if a class scored on a test that had a huge range, okay, that would seem to indicate to the teacher that maybe some students were very well prepared and some were not well prepared at all. Whereas if the range was very small in the class, it means everybody was pretty level on it, and that would be a good thing for a teacher to see. Okay, so that'd be one example, but there'd be lots of examples for range. Okay, next we'll look at the concept of outliers. Okay, well, it's kind of how it sounds. Out is outside or farther away, and liars, it's spelt a little bit different, but where the data lies. Okay, if we had a set of data, okay, so example here, I'll give you a set of data. Okay, a set of numbers: 666, then 11, then 9, then 12, then 8. Then 13, and then 10. Okay, what do we notice when we look at this data closely? A lot of these numbers are pretty close together, right? Kind of 8, 9, 10, 11, 12, 13. And then there's one that's way out there. Okay, that number there would be an outlier. Okay, because it is an extreme. Okay, that'd be one way that you could remember the definition of an outlier. It's an extreme value, okay, either much lower or higher than the rest. Okay, so I'm going to look at some more examples here. Okay, how about 18, 19, 79, 17, 20, and 12. Okay, start going through 18, 19, it's pretty close, 17, 20, even 12's pretty close. Okay, 79 seems way out there, so we would mark that as an outlier. That would be a high outlier. And you know, we might even consider 12, because that's quite a bit lower than the others as an outlier. So we see that this one actually has two sets of outliers. Okay? So it's possible to have more than one outlier. It's also possible to have a set of data that wouldn't have any outliers. So if we had another example, how about 6, 7, 9, 7, 8, 10, and 8. If we look at that, it's kind of all the same, pretty close numbers there. So that would be a set of data that we would say would have no outliers, and that's okay as well. Okay? The last thing we need to talk about is determining which mode of central tendency is most effective for certain things. So we'll go through the three central measures of central tendency again, and give hints on when is best to use it. A mean would be best to use when the numbers are all pretty close together. All close together. The reason being, if you have a very small number or a very big number, outliers, they're going to really alter the overall mean and not give you an accurate picture of what's going on. Okay? The median would be a good choice to use when you have outliers. Okay? And this would be because you're still, remember the way that you find the median is counting in from either end, and so it doesn't matter the value of the numbers you're skipping over, it just matters that there is one measure there. So when you have outliers, a median is often a good one to use, and the mode would be best used when you are representing a frequency of choice, or a tally. So say you're looking at shoe size in a class, and you count up all of the different tallies that you'd make. Using a mode then would be a good choice for that. Okay, so that is all for this section, and you'll be able to complete your unit review now.
Made with Doodlecast Pro.